Hi, we're going to talk about the derivatives in regards to the chain rule and the trig functions.
We're going to do a few examples using multiple choice and free response.
Alright, so first we're going to set up the basic derivatives of trig functions. Okay, so here we have written out the derivatives of the basic trig functions. So I'm just going to go through them with you guys. The derivative of sine of x is cosine of x. The derivative of cosine of x is equal to negative sine of x. The derivative of tangent of x is equal to secant squared x. And we'll be proving this a little bit later on in one of our examples. The derivative of cotangent x is negative cosecant squared x. The derivative of secant of x is equal to secant x tan of x. And the derivative of cosecant x is equal to negative cosecant x cotangent x.
So here we have a practice multiple choice problem. Find dy dx if y is equal to the sine of x cubed minus 5x plus 1. And we're going to use this example showing you the chain rule because you have a list of examples, and if you do the chain rule correctly, you'll find one of these and you'll know that it's right, and some of them have a variation that's not exactly correct. So the basics of the chain rule is that you have an outside function, f of x, and then you have an inside function, g of x. So you have f of g of x, and then to find the derivative of f of g of x, you're going to have f prime of g of x times g prime of x. In the first part, you want to make sure that you don't put g prime of x into f prime of x. So to solve this equation, we're going to do f of x is going to be equal to the sine of x. That's our outside function. And g of x is going to be equal to x cubed minus 5x plus 1. And then f prime of x, as we saw from Francesca, is going to be cosine of x. And then g prime of x is going to be 3x squared minus 5. And if we put those together, we're going to get f prime, so the cosine of g of x, times g prime of x. And that leads us to D.
Okay, so here we have another example for you, and we're going to solve the derivative of y equals tangent of x plus sine of x. But first, before we go through any of the options or solve the problem, I'm going to prove to you the derivative of tangent of x. So the derivative, so tangent of x is equal to sine of x over cosine of x. So when we take the derivative, you can apply the product or the quotient rule to this. So let me take so the derivative of tangent of x is equal to first I will explain the quotient rule. So the quotient rule basically is how you set up the derivative for like a fraction, or to one thing dividing the other. So the quotient rule is the derivative of u over v is equal to u prime times v minus v prime times u over v squared. So this is how you do the derivative of anything that's in this layout, u over v. So as you can see, it's sine of x over cosine of x. So we're going to take u prime, which is cosine of x, because that's the derivative of sine, times v, which is cosine of x. And then you subtract v prime, which is negative sine of x, times u, which is sine of x. all over v squared, which is cosine squared x. Then to simplify that, you get cosine squared x plus sine squared x all over cosine squared x. And by one of the properties of trig functions, cosine squared x plus sine squared x is equal to 1. So you can just simplify that to 1 over cosine squared x. And we know that 1 over cosine squared x is equal to secant squared x. So there you go. Now we've proven that tangent of x, the derivative of tangent of x, is equal to secant squared x. So now we take a look at the problem that we're trying to solve. When you take the derivative of two different objects being added, you can just take the derivative of this one plus the derivative of this one. So y prime of this d over dx of that function is equal to secant squared x plus cosine of x. So then we get answer D.
Okay, so now we're going to do a third example using the chain rule given a function. So we have the function f of x is equal to the square root of x squared plus 1. And then remember from our earlier example that we're going to take a function that's f of g of x, and then the derivative of that, dy dx, of f of g of x is equal to f prime of g of x times g prime of x. And so here in this example, our f of x is going to be root x. So f prime of x is going to be equal to 1/2 x to the negative 1/2. Because the square root of x is also equal to x to the 1/2. And then our g of x is equal to x squared plus 1. So g prime of x is just equal to 2x. So now when we put this together, we're going to do the derivative. So f prime of x is equal to f prime of x. So we have 1/2, and then open bracket it to put g of x in. So you have 1/2 x squared plus 1 raised to the negative 1/2. And then you're just going to multiply it by g prime of x times 2x. So we're left with f prime of x of this function is equal to x times the quantity x squared plus 1 raised to the negative 1/2.